Morning, sir.
Can you hear me?
Yes, sir.
Okay, so I guess we have the exam IOQM in 2 weeks from now, right? So I don't think there is any time to start teaching a new topic. Instead of that, we should focus on more practice problems and not just the problem and the solution, but as always, I would like to focus on the motivation that why should you think of a particular approach? And that dialogue has to happen every time you solve a problem. After that, spend some time to think about what did I miss? If you solve the problem, even then you have to think about what was the most important ideas which I observed because of which I was able to solve the problem. And if you are not able to solve the problem, you look at the hint, you look at the solution. Even after that, you have to think about these points that how if I'm given the same problem next time, then what can I do to try to solve it? Okay. So all of you must have seen the practice test, and I also shared the hints sheet with you. So with those hints, now are you able to solve many of the problems, or are there still any doubts or any questions that you would like me to discuss? So if there are no particular questions from your side to suggest, then I would pick up a couple of questions which I think are interesting to talk about.
I wanted to discuss the 15th question and the 12th question.
Question 12 and 15. Okay. Any other questions? You want to see the paper? Uh, or you also want the paper? Or you have it?
Sir, question number 8.
Any other? Question 9. Thirty. Okay, so we start with these questions. Any others you can suggest? Can you show me the sheet which I shared? No, the one which I gave. Because actually I've written numbers. I mean, I actually made a notes like which questions most people were able to attempt and which you were not. So I'll start with question 13 because that was one which only one or two students got correct. So, so I'll just write the question here again. Okay, is Okay. So how does one start to think about a question like this? There is some information given, there is some sequence, and it seems a pretty abstract question at the moment because there are so many variables, right? I mean, the k, when the value of a2 changes, the whole sequence will change, and we want to predict kind of when that sequence will become zero, right? The at equal to zero is when that sequence will become zero for the first time, and to find out what is that connection of that t with the, so when you change the value of k, the value of t will change. And I mean, you can try some small examples, like for example, uh, and also pay attention to this, like what is this relation that is given. So you are taking the absolute value of the difference of the previous two terms, and like that you keep on computing the next terms, right? So I mean, just for our understanding, can you, for example, let us say I choose k equal to 1, then how will the sequence look like? So a1 is 89, next term will be 1, then after that 88, then 87, then 1, then 86, 86, 85. So you see it is decreasing definitely, and eventually it will reach 0. And if the question was simply find the term where this sequence will become 0, that is relatively straightforward, right? Because we see there is a repeating pattern of 3, right? So after every 3 terms there is 1, and the numbers keep decreasing. So it's a simple matter of extrapolating and finding out when that reaches 0. Okay. Suppose k is equal to 2. Okay. Then for k equal to 2, how does the sequence look like? So now it is 87. Then so you see again it is the same kind of pattern, that now the gap has increased, but at the periodicity is still 3, right? After every third term I'm getting 2. And so now what will be the next term? 83, 81, 2. So you see that both sequences are decreasing, but this is decreasing faster, right? And so because we are interested in finding the smallest index t where this 80 becomes 0. So between these two, which one is preferred for us? Clearly the second one, right? Because that will give a smaller value of t, right?
But it
Whichever
won't
term,
give zero, right? It won't give zero.
it won't give 0 immediately, but so you can work out as the numbers come close to 0, what are the final terms? If you look at those, right?
But the
So
terms will all be odd, right?
yeah, yeah. But because the way this works, right? So let us look at the last few terms. Let us say, for example, the final 3 terms are like you get 5, 3, then 2. And now when you come to the difference, you'll get 1. And now you'll get 1, and then you'll get 0. So at the very last, the pattern will break slightly. It is not like this odd numbers will remain. Finally, you will get some even numbers and it will finish.
Okay.
So these are some small observations that you can have. But uh, considering that k1, k2 are just two values, we have to try. We cannot try out 88 values this way, right? So we need some different approach to think about this problem. So what can we do? Here is one idea. We know that whatever is that best value of k, can we work backwards? We know the last term is going to be 0. Whenever that 80 is 0, what will be the term before that? And what will be the term before that? Can we try to guess that or estimate that what will be those previous terms? Okay. So I mean my sequence, let us say whatever is my 80. So 80 is 0. I'm asking what is the previous term? 80 minus 1 and 80 minus 2. What will the previous two terms be? First they have to be equal because this is the difference. So what are some same value? If I say x and x in both places. Okay. And then what can I say about what the value of x can be? For example, can x be 2? What will go wrong if x is 2? Because if these both are 2, what will the next term be?
4.
4. And what will the next term be? It can be 6 or yeah, it can only be 6, right? It can be 6 or 2, yeah, correct. So it can be 6 or 2, we don't know, one of the two. But no matter which term, do you observe anything about all these numbers? They're all even. So whatever is that x, right? The whole sequence will be divisible by x. Because the way this works, right? This is like if you ignore the modulus sign, if you just look at the divisors, if there is some factor which divides two terms, it has to divide the third term. Right? And so can it be 2? The last two terms, can they be 2? Because otherwise you keep chasing back, eventually you will reach the conclusion that 89 is also even, which is not true, right? So therefore it can be 2. Can it be 3? Can it be 5? Then which value can x be? Okay, why? Because 1 divides 89. But more importantly, nothing else divides 89. 89 is prime. So that is the important observation. 89 is prime. So the only way this sequence can end is 1, 1, 0. We don't know about the thing before that, but the last three terms are 1, 1, 0. Is that clear? It cannot end in anything else. So you see, one important strategy is if you cannot work forwards, work backwards. You know the end position, from there try to work it backwards. So, okay. So the last terms are, so we know the final terms are 0, 1, 1. And after that, what will come?
2.
2. And after that, so it can be either 1 or 3, right? Because in both cases, you will get, so it can be 1 or 3. Okay. But now, first, I mean, let us say, this is understand, this is an IOQM paper. You are not supposed to write the proof. Even if you guess the answer, if it's the correct answer, you are going to get marked. So in your mind, if you want to have that length as small as possible, right? Then should you go this direction or should you go this direction? 3, right? You'll keep, because you want to reach 89 as quickly as possible. Then that sequence will be small. Like if you go from 2 to 1 again, then you have to come back to 3. And if you choose the lower path every time, you'll always have a lesser magnitude. Okay, but if you choose the upper path, you'll always have the larger magnitude. So can you work it from there? What will the next terms be? Like optimistically, how many terms will you require? And then we'll also see how to write this as a proof. If the same question will ask for RMO, it is not enough to guess. But for IOQM, you have to exploit this fact that you can guess the answer. And then you'll see that these were the most easy 5 marks that you can ever earn. So what is this number 89? Why did I choose 89? So does anybody know this sequence? Hmm. So 89 was a Fibonacci number. So understand that what I gave was just Fibonacci numbers recursion reverse. Fibonacci numbers says add the previous two terms. I'm just saying subtract the previous two terms. So just how do you pronounce Fibonacci in its reverse? Equonaf. It's not a word, but that is what we can call this sequence, right? So in how many terms are you reaching 89? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So this is A1. Sorry. This was A1, right? A12 is 0. So at a first glance, this looks like the fastest way to reach 0, right? We are not, that absolute value does not matter. We are just taking the difference. So if you are, in a time crunch, you want to write some answer, you can write 12 and it would be correct. Did you understand how do we guess the answer? I have not said that we have proved the answer because we don't know. Maybe some other term could have given reached 18 and even faster. But as a guess, it is not a bad guess, right? That maybe 12 is the answer. Okay, but now the question is, can we prove this? That why is this a good guess? Or why is it the correct guess? Like with some other value of k. So here we are saying that k has to be 55, right? If I choose k as 55, then I get the 6. But what is the guarantee that with some other value of k, you may reach even 0 even faster? How can we guarantee that that will not happen? But this part is understood, that if in an exam what you should do, and while thinking about this problem at home what you should do are different things. In an exam, you want to score the 5 marks in as little time as possible. Okay. So for the second part, what can we do? Let us look at that relation more closely, right? What is the relation an plus 2 is equal to an plus 1 minus a. Using this relation only, we can say that this is the best possible sequence, that we cannot do any better than this. So whenever you have absolute values, you can rearrange that a little bit and write that in terms of. So when I say this, I'm saying two possibilities: either an plus 2 equals this, or it is the reverse, right? One of these two has to be true. So can you tell me in which of the cases the maximum value will occur? Uh, Actually, I want to go the reverse way. See, because I'm backtracking, right? So let us say I'm given these two terms. I'm given the second last and the last term, and I want to find out the value of an. So rearrange in terms of an. Okay, let us keep an on one side and take everything else on the other side. So then, so this can be written as an is equal to or plus an plus 2, right? And all these AI are going to be positive because they're absolute value, right? Absolute values are always non-negative, not positive, I should say. So these AIs are all going to be non-negative all the time. So therefore, out of these two, which one will be larger? Second one. So can we say that with guarantee that we don't know which path will take? Maybe AN goes this way or this way, but in both cases, can we be sure that AN will necessarily be less than this? Can we guarantee this? Even if it takes the first path, still this statement is true. If it takes the second path, then it's equality, of course. So we have an upper bound on how much the previous term can be.
So we have condition that k should be less than 80.
K should be?
Less than 80.
Yeah, that is there. That actually was not required. Even if I remove that condition, right, the answer is going to be the same. But do you see that this gives upper bound, that if I know the next two terms, then the previous term cannot be more than their sum, no matter what I do. And so do you see that enforces that every term over here is the best possible? Because based on this principle, what I can say, if I label my terms, this is 80, this was 80 minus 1, this is 80 minus 2, and 80 minus 3, etc. Then if I apply this identity again and again, I am saying that 80 minus 3 will be necessarily less than 1 plus 1. Or less than or equal to. Then this will be less than or equal to this plus this. And like that, if you keep working backwards, you will be forced to contour that this term is always less than or equal to 89. If I call this 80 minus 12. So 80 minus 12 is always going to be less than or equal to 89. Okay. And so if some other value of k works, right? I mean, basically what I'm saying is that before this, it is impossible to terminate a sequence because this term will also be less than or equal to 55. So it is impossible to have a sequence which starts at 89 and ends with less than 12 terms remaining. That would be the contradiction. So I don't know if you understood this argument completely, but think about it. Like term by term, I'm applying this sequence again and again. Like I can write it if you want. Basically, if I apply it again and again, my claim is that so 80 is 0, 80 minus 1 is 1. Then applying this, I'm saying that 80 minus 2 is necessarily less than or equal to 80 minus 1 plus 80, which is 1. So 80 minus 2 is less than or equal to 1. And which is less than or equal to. So like that, I keep getting bounds on each term. So therefore, it is impossible that a sequence smaller than 12 can start at 89 and reach 0. That is what I'm saying. Okay. So how you write this is very important. So I would suggest your homework is to try to write this. If the same question is asked for RMO, you are supposed to write the explanation, right? So if you understood this logic, or even if you have not understood this logic, I given you enough hints that you can work out the details. That how will you take this idea and write it into a proper solution for RMO. Okay, so that is your homework. Any doubts online for both questions? First is how do you solve this in exam, and then how do you really solve it? Prove that you cannot do better than this. Okay. And so I think this is a very good example of what kind of approach you're supposed to take at IOQM. Exploit the fact that IOQM gives you this freedom that you don't need to know the proof. A good guess will also give you the marks. And understand that there is no risk because there is no negative marking, right? If there was negative marking, we have to be more careful. But instead of leaving it blank, give it a good guess, right? Okay, this was question 13. Next, can we discuss question 12? Yeah, I'm very curious because I know that I have not given all the details to write this solution completely, but if you can work out the remaining details on your own, then that will be a very good exercise. I don't know where did everything go. So question 12. Question 12 was kind of a trick question because it is talking about triangle ABC. I don't know, our instinct is always to draw an acute angle triangle, but even obtuse angle triangles are triangles. So we have to consider them sometimes. But suppose we don't know that, okay? As usual, let us say, and my triangle looks right angle only. Suppose we draw an acute angle triangle. So let H be the orthocenter. So this question is really about, do you understand 9-point circle configuration completely? Like any angle in a 9-point circle configuration, can you compute? If you can do that, then this question is trivial. X is point. So given find B's. So FQX is given to be equilateral. So when that one phrase equilateral packs a lot of information, right? It is giving so many sides equal, so many angles are given. So where do you start? And every I've tried multiple times. Every approach is valid. If you can chase with angles, you'll get the solution. If you chase with sides, you'll get the solution. So there is no shortage of approaches possible. So it is completely up to us that right now what do you feel like doing? Angles, sides, angles. Okay, so we'll go for angles. So then we have to exploit the fact that angle, and again now which angle? Equilateral triangle has three angles. So which one do you want to first try to compute? Like even keeping this problem aside, can you compute all the angles of this triangle fxq? Or which angles can you compute which are difficult to compute in terms of your angle ABC? So for example, can we come up with a formula for angle fxq? And by the way, where are all these points located? 9-point circle, right? So keeping this problem aside, just try to come up with a formula for angle fxq in terms of ABC. Q is the midpoint of AC. Q is the midpoint of AC, and X is the midpoint of AH. Oh no, wait. Can you explain how you got these terms? Angle A and angle is similar triangles. Why are you calling this angle A? This is vertex A, right? Well, B is C. Okay. And then B is equal to this because of similarity. Yes, yes. And this is 90 minus angle A. It's easier. Yes, that's correct. And this is the midpoint. Yes. And so this is these are equal. This is 90. This is C. This is C. So this is 90 minus C. Yes. And therefore this is 180 minus angle A minus angle C. So it's 180 minus that. So it's A plus C. Okay. XD means you're calling this point D. Uh, I don't know. I don't think so. Depends if you compute the two because you can compute the smaller parts also, right? You can compute fxh and qxh. I don't think it should bisect, right? Okay. Anybody has found the answer online?
Yes, sir.
Okay. Yes.
So if this is 90 minus angle x, if ux equals 90 minus
Yes.
and by midpoint form, this is angle aqx is angle aqx is 90 minus 3. So
Yes.
that's 0.
Yeah. No, I'm just confused. You written XQ, but I asked FXQ. So, but I think this is correct. Okay. Yes. So A plus C or 180 minus B. So one way to do it, one way is that because FXQD is cyclic, so you can compute FDQ and take its supplement, or else I would just say you can find the two separate angles, FXH plus angle QXH, right? And each of them can be found because basically uh, we know that this, because of midpoint theorem, this is parallel, right? This is parallel to this, and so this angle will be equal to this angle, which is equal to B, right? So QXH is equal to B, and how much is FXH? This will be equal to twice of this angle, right? Because these are equal. So this angle is 90 minus B. So therefore this angle will be 180 minus 2B, right? 180 minus 2B. Okay. And similarly, any other way you change, you will get the same answer. Okay. And then, so our question is saying that this is equal to 60 degrees. So angle ABC is 120. Or at least we can see, the thing is all the calculations are slightly configuration dependent. Because when you take, like for example, here I could split FXQ as these two angles, where I'm assuming that XH lies in the interior of that angle. If the triangle from acute becomes obtuse, we don't know like how the lines will change exactly. But we can definitely say that this configuration is not valid. Like ABC cannot be an acute angle triangle. That much we can say with confidence, that otherwise we will get a contradiction, right? Because if ABC is acute angle, then B is 90 less than 90, and then this cannot be equal to 60 degrees. Okay, so therefore, at least this configuration is not valid. And then from here you get the hint that maybe you should consider B as obtuse. Okay. And like this problem involves some case work. Like if you try to do like case wise, so this was, I would say, case one, where triangle ABC is acute, and we saw that this does not work. So similarly, you can try other cases. What if angle A is obtuse, C is obtuse, and B is obtuse? So again, in both cases, you will get some contradiction, that either the angles will not work out, or yes, Raghav.
Sir, I don't think you need casework for this problem.
Okay, but with the angles approach, or you're changing the sides?
Sir, angles approach.
Okay, tell me then, how do we
So,
actually?
yes, sir. So we know that FXQD is concyclic because of 9-point circle.
Yes.
So FQX would be equal to FDX.
FQX equal to FDX. No, again, that depends on the order of the points, right? Or can we be sure always that the order will be like that?
One second.
I mean, if we are sure that there always be cyclic in that FXQD order, even for obtuse angle triangle, then what you are saying we can use, but I am not sure about that.
Okay, I'll just check it.
Yeah. In fact, this is something very interesting. We never investigate this as part of our orthotic configuration, right? We look at 9-point circle, midpoint. We know that they are cyclic, but have you ever asked the question in what order? As you go around the circle, is it necessary that which point comes first, which point comes next? And in which kind of triangle, what is the order? So even I have not thought about these questions before, but they're interesting to think actually. But do you need to make cases or not? Okay, how? Which cyclic quadrilateral?
FX3.
Yeah, but again, that's the question, right? That what is the order of those points? See,
Then I showed that triangle BFD similar to triangle BCA.
yeah, that is true. I mean, that is a standard configuration, right? Now, my question is in FXQD, if you are going to chase angles, I mean, you can have two configurations, right? What if your FXQD are located like this? F, Q, X, and D. Then you can no longer say that FQX and FDX are supplementary. So depending on the order of those points, your approach will change slightly. One way to deal with this difficulty is use directed angles, but we have not done directed angles formally, and you have to be careful with that approach also. So if nothing is worse, you can always make cases and finish the problem, right? But you see, in a time constraint environment like IOQM paper, efficiency is very important. So how can you quickly eliminate cases and get the right idea? So I feel that whenever you're talking about angles, you'll always run into these difficulties. But sides are relatively immune to many of these problems. So can we just restart and think of sides once more? Because just as I asked that in this standard configuration, you should be able to compute any angles. In the same way, you should be able to compute any lengths in terms of other standard quantities. Let me just erase this and ask the question. So let me look at the sides of triangle FQH. Can we write FQ in some way? What can we relate FQ to?
Sir, with AC.
Yeah, it is just half of AC, right? Because triangle AFC is right angled. So this is simply B by 2. And you see, this doesn't depend on whether you're talking about acute or obtuse angle triangle. Triangle AFC will always be right angled, and FQ is one of the radii. Okay. Then which other length can we compute? And FC, FC, no. FC is the altitude, right? That is not AC by 2, right? What about FX and what is the other side? QX. Can we relate those to anything else? So QX,
Sir, QX is 1 half of CH and FX is 1 half of AH.
yes. So FX will be half of AH, right? Because again, that is a right angle triangle. And what about QX? By HC, right? By midpoint theorem, right? So in fact, we can say these three lengths are equal. Let me write AC only here. So therefore, AC equal to AH equal to H. And so actually, what are we saying? AH is equilateral. And do you know this, that if out of these 4 points A, B, C, H, any three are picked, the fourth one is fixed. Like, as obviously, if I give you the points A, B, C, you can find H uniquely. But the reverse is true, because do you know that each of them is the orthocenter of the remaining three, right? Yeah, that's an orthic group. So if I know AH is equilateral triangle, then the whole diagram is uniquely determined. So again, you see how picking the right approach, angles also work, sides also work, but which is faster? Okay, and that could be the difference in how much you score in the exam like IOQM. If you ask me, it is a bit unfortunate. I mean, it should be that anybody who thinks in the right way, they should get the marks. But ultimately, there is some time constraint. And so it matters which approach you pick first. And so if you want to score well, you have to become better at that also. Okay, is this approach clear now? How we can finish the problem much faster? That we know that these are equal, therefore triangle AHC is equilateral. So what I'll do, I'll erase this diagram and I'll just draw a new diagram starting with that given information that ACH is equilateral. So I'll first draw triangle ACH as equilateral, and then from there I'll reconstruct the whole remaining diagram. And then there is only one unique way to do it, right? Because now where will point B lie?
Sir, B will be orthocenter of AX.
I was trying to find B somewhere over here. Okay. And so then, so what was asked, right? Find angle BSC. So BSC is 30 degrees. And then in this, you can confirm that FQX remains equilateral. Like what was the given information? That is true. Because actually, I think FQX turns out to be this one, right? This is Q. F is, what is F? This, right? This is F. And X, which is the midpoint of AH. So, yeah. Okay. So things fall in place very quickly if you look at the sides. Whereas with angles, we have to be a bit more careful. So write down that. What did you learn from a question like this? And the way I put it is that angles is right, but side is more right. It is not in that is not how it works. Either it is right or it is wrong. But for the exam, definitely sides will give you faster results. By the way, it doesn't mean that in every question always sides will give you faster result. So that is where your judgment you have to use. That what will be faster in which problem is something you will learn with experience. Okay, this was question 12. Question 15, somebody wanted to discuss, right? So question 15. And first things first, generally they don't ask 3D geometry in Olympiad, not even with IMO. It used to be there many years ago, but now it's kind of phased out. So 3D geometry is not directly relevant for IMO, but I think it is very important because what you learn in studying what you learn in 3D geometry is visualization. Okay, you're learning to imagine something which is in 3D space, and imagination is very important for Olympiad. So that is why almost every paper which I said, there is always one or two 3D geometry questions. Like even in the selection test paper, you must remember that square pyramid base and like some area was there. So, so how are you able to develop your imaginative capabilities? And just again, the right observation will finish this problem in 2 minutes, not even 9 minutes. So, and I helped you a lot. I was not going to give the diagram also, but I thought let us not be so unfair. So I gave you the diagram. Okay, but do you know this from real life that the shadow of a cube is a hexagon? If you not do this experiment at home, take a Rubik's cube, take a lamp and see, actually look at the shadow. By the way, in real life, it will not be a perfect hexagon because the rays of light will not be necessarily parallel, but ideally it should be hexagon. So then let me draw this different color. So here I'm drawing the equilateral triangle, which will get projected on the base, right? And those will form the alternate corners of your hexagon. And the important observation was that this is parallel to the ground. Therefore, you can take these lines and directly map them to the ground. In general, if you have a surface and you have a slanted lens, then the projection of this, so this length will not be equal to this length, right? This will be shorter than this. But if you have a segment which is parallel to the ground, then its shadow will be equal. So therefore, the side length of the cube we cannot relate to the image on the ground, but this we can. And so if this was, how much was given? This was 3, right? So then this is 3 root 2. And then therefore, the whatever hexagon is formed. That is not a very good hexagon. Something like this. So then this is going to be congruent to that triangle, this yellow triangle. And so then rest of calculation are simple to do. I don't think there is anything difficult. Once you know that this is 3 root 2, then you can connect it to the center and you'll get all the lengths. So I mean, this was not a difficult problem once you see that equilateral triangle, that it is going to project to the base. Okay. So again, when there is a lot of information given, are you efficient at spotting the most important thing? That is what a problem like this comes down to. If you quickly spot that what matters to us is finding one segment which is parallel to the ground, and then from that we can deduce everything else. So I think Anushka, you had asked this question, or
Yes, sir.
yeah, okay. So is this clear that how we are supposed to make progress in this problem? Okay. Yeah, and so I think the final answer turns out. So now once you understand this, you can actually, it is difficult to draw in 3D. So you can draw the diagram in normal coordinate system. And so knowing that this is 3 root 2, so then this is 3. And so you know one side length of a equilateral triangle. So this should be your answer. Again, important time saving device. You should know the standard ratios of all the standard triangles. Like this should be in like templates in your mind. Like remember this, you know how you get for Rangoli, you get stencils. So like that, these should be stencils which are ready in your mind of the standard ratios. Or 36 and 90 triangles, what are the ratios? This is a 120, 30, 30 triangle. Okay. So therefore, once you know this length as 3 root 2, this should be just that divided by root 3. So keep these like ready in your mind and some few others. So you should not be sitting and calculating that. Okay, so that was question 15. Then I think question 10 pretty much everybody got. So it was and there are so many ways to do this question. Again, use the fact that it's an IOQM exam. What is the fastest way to finish question 10? Can somebody tell me? Anybody has very creative ideas to finish this question even without writing a single word? You want to see the paper question? Oh, yeah. That ABCDEF natural numbers given. So I'm going to take more time to write the question on the board than it will take to solve the question. We are interested in these kind of numbers where ABC are in the AP, what DEF are in AP. And what ADB is here. And so we are supposed to count how many such values are there. And you know that IOQM has answers from 00 to 99. Suppose you found one such pair, A, B, C, D, E, F. Can you find one more pair? Suppose you find one pair, six tuple, which has these properties. Can you find one more? What? Just double all the numbers, right? So if ABCDF is a pair, then 2A, 2B, 2C, they are also pair. So if you get one pair, you are going to get infinitely many pairs. And you cannot write infinite in your IOQM sheet. So the answer has to be 0. Why do you do any rough work for this question? You don't need to. Understood? Those are online. How you can finish the question without writing a single word. If there exists one solution, there are going to exist infinitely many solutions. And so the only conclusion is there is no solution at all. Okay, but that will not work in RMO. So suppose the same question is asked in RMO, then you know what to do. I think everybody got it, right? Ultimately, you get the conclusion that whatever is this gap, right? If I call this gap X and Y, then you get that XY product has to be 0. And that will force that the terms are equal, which is not allowed because I'm given A less than B less than C, right? Okay. But so even in that, understand what is the most efficient observation that you can characterize AP in terms of two elements. Okay, so like for example, I can write this as B plus X and B minus X. So that just the two variables B and X capture all the information of the first sequence. And similarly, the second one I can write as E plus Y and E minus Y. Okay. So the principle is always try to introduce the least number of variables that you are required and then solve everything in terms of those variables, right? And then when you multiply, as I said, that you will get XY equal to 0 finally. And so that gives you the contradiction. Okay. So you see, every question has two dimensions: how to solve it in IOQM and how to solve it in RMO. Okay, this was question 10. What about question 9? Question 9 is that circle of radius 363. So you want a circle which is tangent to both the segment and the circle, right? Maybe something like this. And its radius is given to be R. If I call this point P. So what is the relation that you can obtain for R and OT? So you have to exploit the tangency, right? So what is one way to say that two circles are tangent? Collinear is correct. And so in terms of distances or anything like that,
So distance between centers are difference of radii.
so the distance is either difference or sum, right? Depending on internal or external tangency, right? So here we are talking about internal tangency. So therefore OP will be equal to, and I know the radius of my main circle, right? So 363 minus R. So we have used this tangency. And what about the tangency of this one, PT? How do we use this now? Pythagoras theorem. So therefore, I think we have all the parts required now. So 363 minus R. What is happening to this? Is equal to, and we are interested in the R and OT being natural numbers. And we have to find the number of distinct values of R. Okay, so how do we rearrange this? R square will get cancelled. So we get 363 square minus and no, R square will get cancelled, right? R square will get cancelled.
Then bracket will open and then the R square will.
And there is R square over there also, right? Calculator. Did you write this minus R square? Okay, that is the other unfortunate thing about IOQM, that if you make silly mistakes, at the very last step, if you make a silly mistake and instead of 35 you write 36, you will get 0 marks. That is unfortunate truth about IOQM. In RMO, it doesn't happen that way. We are very considerate that if it's a silly mistake, we'll give you almost all the marks. Like we may cut 1 or 2 marks, but you will get majority of the marks. But in IOQM, that is not there. So you have to be extra careful. Doesn't mean you can be careless in RMO, but sometimes it is okay. So then we have to use the fact that OT is a natural number, right? So I'm expecting this to be a perfect square, right? So how can I rearrange this 36 to 26? Sorry. This I want to be a perfect square. And I'm interested what are the values of R for which this will happen. Correct, because this is already, like we know that when perfect square always have factors in groups of 2, right? So anything that is not matched here has to be matched by this bracket, right? So if this is like 3 times 11 square times whatever. So then whatever is this times also has to be of the form 3 times some k square. But in addition, so this much is enough, that if I find all the values of R which satisfy this requirement, 363 minus 2R is equal to 3k square. Okay.
So R has to be divisible by 3. 0 mod 3.
Yes, R has to be divisible by 3, correct? So instead of putting conditions on R, why don't we put conditions on K, that what are the values of K which are allowed?
So K will be less than equal to 11.
Yes. So K will be less than equal to 11 and K will be odd also, correct, right? Because left hand side is odd, so RH is also odd. So K has to be less than 11, K is odd. Is that sufficient? Okay. So then just rearranging this in terms of, let us keep 2R to one side and take everything else there. So 2R will be equal to 3 times. Right. And so how many such values of K will we get? Less than 11, 1, 3, 5, 7, 9. And each of them will give you one value of R. And even if K is negative, like actually if you think about it, I can draw this same circle on the left hand side also, right? So that you can think of like OT become negative, but R will be still positive. So it doesn't give us additional solutions. Like instead of +1, if you consider -1, you'll still get the same value of R. So
But sir, if they have told find the number of values of OT, will it be then multiplied by 2, or we won't consider the direction?
yeah, because generally you don't take sign distances into account, right?
Yeah.
Like in school geometry, this is not a thing. So yeah, you should not consider it as a sign thing.
So it will still be 5.
It will still be 5, correct? I mean, only case where it will matter if it's, let's say, coordinate system, right? And I'm talking about the coordinate of the point T. then the direction matters, right?
Yeah.
Because coordinate positive. So mostly I don't think the question will be framed like that. So it is safe to say that is also 5. Okay, so this was question 9. So again, what did you learn from this question? I don't know how. Only 3 students got this question correct. If you ask me, it is not that difficult. So what went wrong? You have to go back and think. So actually, this is very important. When you after this lecture, when you go home and look at the paper once more, classify your mistakes. That why you were not able to solve each question. Like there can be 3-4 reasons why you couldn't solve the question. So question 1 is that. Oh, it's not question 1. Reason 1. So reason 1 why I did not get the question is that you got everything, but you made a silly mistake. So you understood the correct approach, you did all the calculations right, except for one small mistake. So that could be one reason. Reason 2 is that you did not get the right approach. Okay. Right. Reason 2 is that no matter how much time you spend, you're not getting the right approach. It is not a time constraint that even after you go home and spend more time, you're not able to get the right idea. Reason 3 could be simply lack of time. That if you attempt the same question at home with as much time as you require, you are going to get it. Right? And any other reasons why you may think that you may are not getting a question from your own like analysis?
Got half of the solution.
Okay, you could do half of the solution, but why could you not do the remaining half? Was it because of lack of time or you got stuck somewhere?
That will be in 2 like stuck somewhere.
Like point 2 can be written as 2 dash, like got half of the approach. Okay, so reached halfway. So you made some progress, but did not finish the question, maybe something like this. So once you understand every question from these angles, that which question you were not able to get, then you know what you need to improve upon. Like if it is lack of time, then you have to become more efficient. Like if there are 3 possible ways to proceed, how do you pick the right approach quickly? Or how do you simplify calculations? Are you doing a lot of unnecessary things? Understand one thing, the mind is faster than the hand. So many times when you're writing calculations, you're wasting time. If you do that same calculation in your mind, you may finish in 30 seconds less. But of course, accuracy also matters. So there is no point doing it in your mind if you're going to make mistakes. So that is your own judgment. That if ideal situation is if somebody can be efficient as well as accurate, then there is no obstacle for them. But you have to pick what is optimal for you. Somebody knows that I tend to make a lot of mistakes, so let me write down everything. So then you know that you are going to be very accurate, but you are going to pay the price in terms of time. Somebody can go the other direction. Let me do everything in your mind. So you'll be doing questions very fast, but you may make mistakes. Okay? Both strategies are valid. Somebody will say, I want to do all 15 questions. I don't want to say that I could not attempt 3 questions because I ran out of time. So I'll attempt 15 questions, but because of my high run rate, I make mistakes. So out of 15, I'll only get 10 correct. Maybe good enough to clear IOQM. Somebody else will be saying, no, I cannot run this fast. I'll only attempt 10 questions, but I'll get all the 10 correct. I am that confident. So every person can have a different approach. And what works for you, I cannot say. From your own practice, you have to pick the right approach. Okay? But think about all of these perspectives that कुठे चूक होते? What is the reason why you're getting stuck? If you understand that, then you can work on it. Okay. So again, this like the question we did right now, I don't fully understand why only 3 students got it. I don't think this is that difficult. Because was there anything that you did not know? Everybody knows Pythagoras theorem. Everybody knows that when circles are tangent, you can find the distance. Everybody knows this property that if you are perfect squares, we have not done number theory formally, but this is something you learn at scholarship, school scholarship also. Like you need to pair up the prime numbers. So all the ingredients are there. You just need to put them together. Okay, so this was question 9. Any other question? 8 again, actually only 3 students have done it, but did you understand it? Maybe after going home, looking at the hint that rook and bishop placing on the chessboard, that question. Okay. Again, there is a lot of learning value in a question like that also. Okay, let me discuss question 8 just briefly. So question 8 was on a chessboard. You supposed to place a rook somewhere and a bishop somewhere. Says that they don't attack each other. So again, I hope everybody knows how rook and bishop moves. I had given it there also. So rook attacks vertically, horizontally, bishop attacks diagonally. And so how many ways are there to place these two? So so how do you think of a problem like this? Forget the hint or solution which I gave. If you are thinking about this problem for the first time, what will you think of trying first? What will you think of trying next?
All possible ways of placing them, and then
Yes.
I tried to find the complement of what.
Yes. So that's a good idea. Let us first place them without any restrictions and then remove the cases which we don't want. And one good thing is that rook and bishop are such that they can never attack each other. So there will be no double counting that way. So first count all possible placements without any restrictions. Then minus from that the number of cases where the rook attacks bishop. And then subtract the cases where the bishop attacks rook. And ordinary inclusion exclusion, we have double eliminated the cases where rook and bishop both attack each other. But thankfully that case is 0 here, right? So therefore that term is not there. Okay, so do you understand this in the framework of inclusion exclusion principle? That if I denote this as two sets, right? So this is the set where rook attacks bishop, and this is the set where bishop attacks rook. So then this is 0. So therefore it is just enough to count these two. Okay. And so then that is how you can do it. So and out of that, I think this is very easy to, right? All possible placement is simply 64 into 63, right? Because you'll first place the rook anywhere you want, and then you'll place the bishop. Then let us subtract the cases where the rook attacks the bishop. So how do you calculate that? So when the rook attacks bishop, again first let us place the rook. So in how many ways can we place the rook? 64 ways, right? And in now how many ways can we place the bishop? 14, right?
15.
15, right? So that row and that column, except that, or no, is it 14 or 15? 14, yes.
15.
No, 15 includes this square, right? We have to exclude this column has 8 squares, this row has 8 squares. So their total, and this square is counted twice. So there are 15 squares in this region, and out of that, rook is already on 1. So actually the answer is 14. Or another way to say is that rook attacks 7 squares in its vertical column and 7 squares in its horizontal column. Okay. So therefore 14. And what about bishop attacks rook? So bishop attacks rook. Actually, the thing about rook is that wherever you place it, it is always going to attack 14 squares. But bishop is not like that, right? If anybody who plays chess who knows that it's always nice to have bishop towards the center of the board, because it attacks more squares at the center and less squares at the side. So do you know how the number of squares varies as the bishop goes from the center to the side? That is the important thing. Okay. So as it turns out, you can divide the square chessboard into these rings. Okay? So this is the outermost ring, the one next to that, and finally the 4 central squares. So as you go from the center to the side, the number of squares that the bishop attacks keeps decreasing. And so you can just count that. So for example, when the bishop is over here, 21, 9, 7, no? Just the diagonal. So anywhere on this outer ring, the bishop is going to attack 7. What was 21? I don't understand.
Right outer. The ways in which it attacks the right.
I don't know what is 21. Okay, don't know. Anyway, but so here the number is 7, and so what you'll observe is that anywhere along this outer ring, the answer is 7. So anywhere where the bishop is kept in that outer ring, the answer is 7. Okay. So what should I say? And so how many squares are there in that outer ring?
28.
28, correct? Because you can think of it as 4 groups of 7 attached together, right? Like this kind of a formation. So there are 4 such groups of 7 each. So therefore the total possibilities here are, so bishop can be placed in 28 ways. And for each of those ways, the rook has 7 possibilities. Because understand, we're counting this case where bishop is attacking the rook. So therefore, anywhere in the outer ring, 28 into 7. Now, if you go one ring inside, both these numbers will change. So how many squares are there in that ring? That will decrease by how much? That will decrease by 4. Because in each direction, like imagine that each of these orange squares is cut by 1. So the inner ring is of size like this, right? So actually it is not 4, actually 5. So this is 5. So 20 only. So 20, and the number of squares that the bishop attacks increases. Because in this corner, the bishop only had access to this diagonal. But now the bishop is here. So now it is continuing to attack this diagonal, but it has gained 2 additional squares here, right? This square and this square. So the number of square it attacks is increased by 2. And the same pattern continues. So the next inner ring is of only 12 squares. And there it will at 11. And finally, so if you add up all this, you will get this term. Okay. So actually you can do this problem without making these cases also. Because whatever, no, what rather what I want to say, you can do this problem without writing this complement, all of this also. See, this you have to do anyway. In that same diagram, you can finish the whole problem. You don't need to do the first counting separately and second counting separately. In one diagram itself, you can finish the problem. Because what can we do? Let us say I want to do direct counting, not like complement principle. I want to do direct counting. So again, same as before, I'll divide the board into rings. Okay, let us look at the outermost ring. So first I'll say that the bishop in ring 1. So if I call this ring number 1. So if the bishop is placed in ring number 1, how many positions are there for the bishop? 28, right? And now in the same thing I ask that how many positions are there for the rook? So if you think about it, any square I choose here, right? Maybe the corner square or any square in between, the same 7 squares, the 7 which I wrote, where all the squares which the rook is not allowed. So those 7 squares are not allowed for the rook. In addition, which other squares are not allowed for the rook? That row
All
and,
where the bishop is.
that row and column, right? So wherever that bishop is placed, that row and that column is also not allowed for the rook, because then the rook will attack the bishop. So how many squares are those? 14, right? And of course, the square where the bishop is standing currently. So all of these squares are not allowed. So 64 minus this is allowed for the rook, right? So rook has, how much is that number? 42. So bishop in ring 1, 28 possibilities for the bishop into 42 possibilities for the rook. And now you see what is going to happen when I shift the bishop in one ring inside. How will these two numbers change? When the bishop is in the second ring, ring number 2, the number of places for the bishop has become now 20. But along with that, because the bishop is going to attack 2 extra squares, so this number also come down to 40, right? Because say out of this calculation, this part is not going to change. This 14 plus 1 is not going to change, because always the rook will be prevented from being in these 14 positions and the one square where the bishop is standing. But this number will become 9. So therefore, this is 40. And then next it will be 38. And finally, so you can just add this and you'll get the answer. Okay, and so maybe as an exercise, try both approaches. So this is a direct counting approach, and the previous was the complement principles, and you should get the same answer. Okay, this was question 8. So again, what did you learn? That how are you going to make the cases efficiently? In counting problems, that is one important decision, that how are you going to make the cases? Okay, question 7. Only one student got it. I'm not sure who got question 7. Can you raise your hand?
Sir, I got question 7.
Okay, yes, Harini. So can you explain how do you get it? Just a minute, I'll just write the question on the board first. So I've given a set of numbers from 1 to 100, and I'm interested in finding the smallest n such that for any subset of the my given set where I've taken n elements of my original set, there exists such that so this is like a chain of divisors, that one number divides the second number divides the third number. And so what is the smallest number of elements that if we pick those many, you are guaranteed to get the sequence?
Sir, actually, my method for this was not very good, as I just tried 75 since it seemed very intuitive, 25, 50, 100.
Okay.
But then I was getting a type of set where 75 would not work, and then I was attempting it for 76. So if there's a proper solution to this, I don't know.
Okay. Okay, so actually this question is related to what is called pigeonhole principle. Have you heard of this term, pigeonhole principle? Can somebody tell me what is the principle? If you have n boxes and more than n objects, and if you try to put them, one of the boxes has to contain more than one object, right? So there's before solving this question, we need to do that question. There is one more question which we need to solve first. So let me talk about that. So suppose same question, that given the same set, like I don't know how much practice you have applying pigeonhole principles. Have you done this in regular lectures? You have done. Okay. So then, for like, if I ask a simple question like, if we pick 51 numbers from S, prove that are consecutive. Is this true? And how do you do that? If I choose 51 numbers out of 100 1 to 100, some two numbers will have to be consecutive. Yes, why?
Because there are 50 non-consecutive, 1, 3, 5, 7, or 2, 4, 6, 8, even.
But the way I pick is I may not pick 1, 3, 5, 7. I may pick anything from between. So
Sir, we can divide 100 into 50 subset of 1, 2, 3, 4, and by PHP we can say that we will take one whole set.
okay, do you
We
follow?
will take
Yes.
We can consider a set of odd numbers
Okay.
till 100 and even numbers.
Okay, and
So there would be at least 2.
so that's what he's saying, but I'm not convinced. See, if I pick the whole set of odd numbers and then I pick one even number, obviously it will be consecutive. But I may pick 10 odd numbers and 31 even numbers.
In that set of 51 numbers, we consider the pairs of numbers, and then the continuous in the original principle will be the difference, like maximum is 99 we could have, and the number of pairs will be 51 squared. So,
Hmm.
in the container where the difference is 1, it's consecutive, that should be more than 1.
I don't know about your approach. I think we are making it more complicated than required. So what Ohm said, I think that is a very simple way. So always in pigeonhole principle, the question is what are the objects and what are the boxes? So here the objects are clearly these 51 numbers. And what are the boxes we should pick, which will force this condition that two numbers will be consecutive. So which boxes should we pick? And if we are trying to put 51 objects, then how many boxes will we require? If we have 50 boxes, then we can apply pigeonhole principle, right? So the question is what 50 boxes? And you have 100 numbers. So what are the boxes that come to your mind?
Subset of 2 consecutive.
50 subset of two consecutive numbers, right? So let me pick the boxes as 1, 2, 3, 4, 5, 6, up to 19 and 100. So these are my 50 boxes. And whatever numbers I'm going to pick, right? So whichever number is picked, I will put it in that box. So I'm going to take 51 numbers and put them in 50 boxes. So some two numbers will be in the same box. Okay. So important is how you write this argument. So let me write it the way I would write in RMO. Okay. Okay, so I'm just writing it. The what? So I'm just writing it the way you can write in exam. But I hope everybody understands this principle that how we are splitting that objects and boxes. So in the same way, there is one more thing which happens when you take 51 numbers out of 100. That there will be two numbers such that one is a factor of the other. Okay. Have you done this problem as part of your standard pigeonhole principle set? Some people are saying yes, some are saying no. So I don't know. Okay, so the next question is, so let again the same set and let T be a subset of S with 51 elements. Then prove that there exist two elements of T such that A divides B. Okay. So can you raise your hand, those who know this question already? Swami, anybody online who knows this question? Anushka, Mihir. Okay. Okay, so majority of you don't know this question. Then let us first try to solve this question. So understand that to apply pigeonhole principle, we need the boxes in such a way that if two elements are there in that box, then that will solve our problem. You see that what's happened in the previous question, that we had picked those consecutive numbers as the boxes so that if two numbers are in the same box, that is what we wanted. So we have to form the boxes accordingly, right? Here also. So how will you create the boxes in such a way that if two elements belong to the same box, then one will divide the other. Can you imagine what those boxes will be? Like somebody may have the idea, let us take all the multiples of one number. Like if I take the entire multiplication table of 2, like 2, 4, 6, 8, etc. And if I pick 2 and some other number in that, then obviously 2 will divide that number. But what if I pick 4 and 6? So the condition is any two numbers in that box have to divide, one has to divide the other. So firstly, does such a set also exist? Where any two elements you pick of that? Yeah, power of any number is like that, right? So 1, 2, 2 square, 2 raised to 3. All the powers of 2 have this property. So as I try to partition this set into these boxes, so the first box can be that, right? So box 1 or partition 1 is simply 1, 2, 2 square, etc. I mean, what is the last one that will come? 2 raised to 6, right? 64. After that, the next term is beyond 100. So this can be box 1. So you see, this box satisfies this requirement. If by pigeonhole principle, I can say that two elements belong to this box, then I'm done. But these are just 6 or 7 terms. But along the same principle, can we classify all the other terms? So 1 and 2 have already been classified. 3 is not there in any box currently. So what can be the next box I consider?
Power of 3.
For
3 into 2 square.
yes. So there are two suggestions here. One is saying, let us take powers of 3. So 3, 3 square, 3 cube, like that. And somebody else is saying 3 times 2, 3 times 2 square, etc. So which one do you think will be more useful? If you go by this powers approach, right, there are so many numbers which are not powers of anything, then they will not get classified at all. Like 3 2s are 6. And you cannot put every number in its own box. Then you'll get 100 boxes. To apply pigeonhole principle, you require 50 boxes only. So you see that second approach looks little bit more promising. And now if you look at the general trend, see every number can be split into these two terms, right? The part which is divisible by 2 and the part which is not divisible by 2, right? So any number in my set can be written as 2 raised to k times some q, such that q is odd, correct? So I take all the powers of 2 to one side and all the remaining terms I group together as q. Okay, then do you see that this is gives a good way of partitioning our set? Because if this q is odd, how many values of q are possible? 50, right? All the odd numbers up to 100. So 1, 3, 5, 7 up to 99. So naturally it is giving me 50 boxes, right? So like what I'll say is box number 1 is this. Box number 3 is 3 into 2, 3 into 2 square, etc. In general, box number q will be all the numbers of this form, right? Such that k can be 0 also, and of course the number has to be less than 100 because we are talking about s. And you see this sequence satisfies the property that any two numbers you take, like suppose you take 2 raised to k times q and 2 raised to l times q, then depending on which is larger or smaller, one will divide the other. And so you see, so we have 50 boxes and 51 objects. So some two will go into the same box. Okay, this is actually a very standard problem in pigeonhole principle. Anytime if you read a textbook, this will be the second or third problem you will attempt. It is very standard. And also, does this give you a recipe that suppose I want to create a set of 50 elements which does not have this property, then what can I do?
51, 52, 53 up to 100.
Yes. So I can take the largest number from each box. Or what Anushka is saying, take the number from 51 to 100. Okay. Why will the set 51 to 100 not have this property? Anushka?
Because smallest multiple, other multiple of 51 is 102, which is greater than any other element from the set.
Yes. Right? Understood? That the numbers are in such that they are too close to each other. So one cannot be the multiple of the other, right? If whenever you have two numbers, like if I have A divides B and they are not equal, then at least B has to be twice of A, right? And so that gap in between, not yeah, correct.
Even
no.
50 to 99 would work then, right?
Sorry, which one? 50 to 99 will also work. Yes. 50 to 99 will also work. So this puts a restriction that if your number is very close, then it will not work. Okay. So there exists a 50 element subset without this property, but any 51 element subset will have to have two numbers which divide each other.
99 will work, but the lower bound should be, you cannot go below that.
Yeah, I mean
49 to 98. Then 98 will come to the second.
But then what I can do just to eliminate that possibility, instead of 98, I'll choose 99. I can make some small adjustment, right? So I'll choose a number from 49 to 97 plus 99. Something like that I can do if required. So clearly there are many such sets, 50 element sets which have this property. Okay, so I hope this problem we have everybody understood that how we are applying pigeonhole principle, like how do we form the boxes and everything. And importantly, how do we come with the condition of when this property is not true. Okay, so if you understood this, then let's go back to our original question, because in a way you'll see it that is a natural extension of this question. Oh, person is different page. Yes, fine. So this question 7, which you want to do, you see it is in some way extension of that question, because there you had to have two elements where A divides B. Now you have A divides B and B divides C. So based on that understanding, yes, A divides C, but how can you pick that largest set which will not have this property? What will you do to create that set?
Same method,
Yes.
26, 27, 28 up to 100.
Yes. So you'll apply the same idea 2 times, right? Because what observation we had earlier, that A divides B means that B has to be at least 2 times A, and C divides B means C has to be at least 2 times B. So if I combine this, I'm saying C has to be at least 4 times A. So that gives you the idea that if I start from 100 and keep going backwards, 100, 99, 98, and I stop at 100 upon 4. So 25 I will not pick, but the number just after 25. So 26 up to 100. Do you see that they are so close to each other that this will never happen? The smallest term that you have 26, 4 times that is more than 100, right? So therefore this set 26 to 100 will definitely not have that property. And then to that, if you add one element, it will have the property. So the what is asked, the smallest n such that this is true, you can guess that the answer is 76, because this is a 75 element subset. So therefore, if I have 76 elements, then some 3 of them will have this property, A divides B and B divides C. But that is a guess, we have not proved it. But that is an exercise for you, that based on what we did earlier, I think you can prove it now. Okay, so everybody clear online also? How do we arrive at the guess of 75 or 76 rather? We just applied that principle 2 times. So first, you can almost imagine that first we did it for 50 to 100, and then that set itself we reduced one more time to 26 to 50, so that we get total 75. Okay, that was question 7. Yeah, but as I said, we have not completed this. I have not proven why 76 is the best possible. Like if I take any 76 element subset, why will I get those ABC? That is your exercise to try at home. Okay, question 6. Again, question 6, only one person has solved.
In this question, I applied Fibonacci, but then at the end, I couldn't get the answer. Like, I got confused how to proceed. I got it in terms of n and all that stuff.
Actually, it is not strictly Fibonacci because the starting terms are 1 and 3, right? So I don't think we
As
get.
like after few terms, the numerator and denominator follow the Fibonacci.
They follow the Fibonacci pattern, but the actual terms are not the Fibonacci ones, as far as I know.
Yeah, like the numerator and denominator separately follow the.
Yes, yes. Okay. So what is given in question 6? Is A1 is 1 by 3, and this recursion is given an plus 1 is 1 upon 1 plus an. And finally, you are supposed to talk about A100 in terms of its numerator and denominator. So one first thing that you can try to think about is, why don't we come up with the recursive expression for the numerator and denominator separately? Like we know that they are all going to be rational numbers. So why don't we represent them as rational numbers from the start itself? So let me define AI or AN as Pn upon Qn, where P and Q are co-prime. And then I can try to see what is the pattern of Pn plus 1 and Qn plus 1 with respect to previous 2 terms. So can we compute that?
Yeah.
how will you compute Pn plus 1 and Qn plus 1 in terms of Pn and Qn?
Pn plus 1 is equal to Qn
Okay.
and Qn plus 1 is equal to Pn plus Qn.
Okay. Okay. Yeah, I think you are right. Because if I expand this, right, so I can write An plus 1, or rather, let me write it as Pn plus 1 upon Qn plus 1 is equal to 1 upon 1 plus, and if I rearrange this, I get Qn upon Pn plus 2. This is equal to. But one important thing we have to answer here is, how are we sure that it is not like what we call equivalent fraction, that something common may get cancelled and these are not term by term equal? That can happen, right, Anushka?
Yes, sir.
Yes. So how are we sure that Pn plus 1 is equal to Qn and not some constant times Qn, and this is also like constant times Pn plus Qn? Why should they be equal?
Sir, because Qn plus 1, sorry, Qn and Pn plus Qn is co-prime to each other.
What are you saying?
The Qn and Pn plus Qn is co-prime to each other.
Yes, yes, correct. So we can use that. We know the starting values, right? 1 and 3. They are co-prime. So if Pn and Qn are co-prime, we can be sure that, so Pn, Qn co-prime, the GCD will be also equal to Pn plus Qn comma Qn, right? So therefore these are guaranteed to be co-prime, and so if they are co-prime, then they will be equal term by term, right? So therefore Pn plus 1 plus Qn and Qn plus 1. Okay. And so if we have this information, we can make a table, right, of the values of Pn and Qn. And what will that table look like? So here let me write n, which I don't really care about, Pn and Qn. So if I make this table, starting with value of 1, which is 1 by 3. So here Pn and Qn 1 and 3. And so each time the rule is Pn plus 1 is Qn. So the term I'll just copy diagonally, and this term is the sum of these two, right? So if I keep following that pattern, I can write the remaining terms, right? So this second one is 3 and 4. Third one is 4 and 7. And now what I'm asked to find out is the remainder of P plus Q on dividing by 12. Right? So I can write Pn plus Qn also here. Actually, Pn plus Qn is already present in the next term, but just for clarity, let us write it here. And I'm interested in the remainder by 3 and by 4. Then I can use that information together to find the remainder modulo 12. Okay, and 3 and 4 will give you smaller remainders also. It will be easier to track. So if I write the remainder with 3 and remainder with 4 of each term, so how much is the remainder here? Modulo 4 is 0. Okay, so I've just written the remainders of this Pn plus Qn. If I divide by 3 and by 4, how much is the remainder I get? And if you write the first few terms, you'll see that both sequences are cyclic, periodic. After a while, the terms repeat. Okay, if you write sufficient number of terms, like if I just continue to write it here. Okay, let me just write these many terms. And so every time I'm writing the remainder modulo 3. And wait, there's a mistake. Okay, it's correct. Fine. So actually, what you will notice in this column, right? The same like Fibonacci pattern is happening. That each number is the sum of the previous two terms. Do you see that? 1 plus 1 is 2. 1 plus 2 is 3, but modulo 3 that becomes 0. 2 plus 0 is 2. 0 plus 2 is 2. So the same Fibonacci pattern is continuing here. And so actually, once you observe that, you don't have to keep writing this. You can just write the last two columns without having to update the left side. So now if you see here, I'm making some mistake.
So it's 1, right?
Yeah, one. Yes, okay, fine. And so the thing is, as soon as you get the same pair repeated, after that it is going to repeat. So here I'm going to get 0, 1, 1. And you see this was 1, 1. So once you get the same 1, 1 again, it is going to keep repeating. So after how many terms is it repeating that way? So 1, 2, 3, 4, 5, 6, 7, 8, right? So after this is cycle of 8, right? This was A1 for which this happened, and this is A9. So after every 8 terms, that pattern is repeating. And what is the case for this? 6, right? 1, 3, 0. Yes. So this was 6. So basically mod 3 cycle repeats after 8 terms and mod 4 cycle repeats after every 6 terms. So if I take the LCM, like mod 12, the remainders will repeat after every 24 terms, right? And so basically whatever is the answer for A100 will be the same answer for A4 also. Okay, so all you have to do is find A4. So A4 is this one, right? And so the answer is 18 here. And actually, so I wrote 18 by mistake in my answer key, but I forgot. Remainder modulo 12 is 6 only. I think this was slightly difficult question for 3 marks maybe, but you never know. You can never be sure that sometimes 3-mark question can be easy and sometimes it can be difficult also. But I hope the approach is clear that what did we do first? We first looked at the Pn and Qn separately. We found that recurrence relation, right? That how we can translate the given information from this, we got this first. And then given that the original numbers are co-prime, therefore we can be sure that they are equal term by term. And that gives us the way to build this table and understand that we don't have to compute the remainder with 12 directly. We can do it with 3 and 4 separately. And do you see that advantage of doing with 3 and 4 separately? If you didn't do that, you have to write the first 24 terms before you start to see the repetition happening. But here in the first 8 terms only, we started to see the repetition. So splitting that 24, the 12 into 3 and 4 was important. Okay. Okay, so I think we have discussed all the questions of section B and of most of questions of section C. Section A, I think is you can do it. I think the hints given were sufficient to solve that part, right? But as I said that we are not done. Like we discussed the questions, we found the solutions. But after that, when you go home, you still have to do some work. That which questions you are not able to do. Why did you get stuck? That is what you need to understand, analyze, and try to incorporate those improvements in your practice, like for the next 2 weeks, whatever you are going to do. So what I'm going to do is I'm going to keep giving you practice questions on the WhatsApp group, which you can try, and we'll discuss next Sunday, right? So I guess we only have one Sunday before the exam, right? The one after that is the exam, right? So the next Sunday will be our last lecture before IOQM. Of course, we'll continue to meet after that also, because we are going to keep preparing for RMO, INMO, etc. Okay? So we'll see what to do after the exam. But for the next Sunday, I'll give you some more practice questions. Okay. I think we still have 10 minutes. What do you want to do? Third question. So it's just the GCD of the three numbers, right? What is your question? So I mean, you did understand that that is what we are defining G of Mn, right? So if the G of Mn, it's a function. So it's a function which takes two inputs, and it is the GCD of those three terms, m square, mn, and m square. So if, like for example, what is the G of Mn of 2, 5? It will be the GCD of 4, 10, and 25. This is 1. My GCD is correct. I don't think that is standard notation. So one notation people use is just bracket without any symbol. I don't think small letter G is not standard notation for doing GCD, as far as I know at least. Okay. So given what? I mean, there are infinitely many circles, ना त्यातला कुठला तुला construct करायचा? कोणताही? तो काय तू कुठलाही करू शकतो. कळलं नाही. What you can do is draw any diameter. Okay, I got it. कोणताही कुठला करू. So one way is we have solved that question, so we know the relation of the radius and OT. That is one way to do it. That if let us say I know that this is the point T where let us say, so this is a good question. Suppose I give you this point T, this vertex O. So now use ruler and compass to construct the circle which is tangent to this diameter and this circle. So passing through this point and tangent like this. So how will you construct this with ruler and compass? Something like that maybe. So one way to do it is, now we know the relation, so we can compute R, right? We can compute small r in terms of OT. I just draw the circle, but that is not very elegant. So what else can we do? Did you understand the question online? You have to construct this yellow circle given the original white circle and points O and T. So how will you construct this with ruler and compass? Okay.
So first, I think we should draw perpendicular from.
Wait, Anushka. Yes. But do you know how to intersect an ellipse with a line? We cannot draw an ellipse with ruler and compass, right? But your point is correct. It is a constant. Yes, Anushka.
If we get the first locus of the center, and that is M, we can draw the perpendicular from T or like
Yes.
on a diameter.
Yes. So this line is one locus of the point M, but we need one more locus, right?
Sir, then can we can take a radius of the larger circle minus the radius of smaller circle and cut a arc on the locus.
No, but we don't know the radius of the smaller circle, right? We are only given the point T.
Sir, then we can use the Pythagoras theorem that OT square is equal to 360 minus
Yeah.
R square.
Let us call this capital R for the moment. So OT square, yeah, the relation that we have earlier, OT square is equal to, so it will be OM square minus, like OM is R minus R, right? So yeah, that is there certainly, and we can solve for small r, right? But that is a algebraic way of doing it. What we are trying to find out is there a way to do this with just pure geometry. Have you seen this expression before?
Yeah.
Yes. Yeah. I don't know if that has any connection to this problem, but just interesting observation. So if that has any importance over here, what that means is
Some triangle ABC O becomes the circumcenter and
I
becomes the infant.
not M, T, right? This is OT.
And 3.11 that point.
There has to be a way to use this, I'm sure, but I don't know how right now, but there has to be a way to use this.
And I think that triangle should be IC.
There is a very interesting way to use this. You're right. This was completely by accident. And naturally I used the capital R and small r, so we saw that relation. Otherwise, we would have realized also. So this is what I would like to suggest to you. Forget that yellow circle. We are interested in finding that radius small r, right? So what if I draw this diagram? The point O is there, and let us call it I, because now that is what we want to do, right? Forget T. Our point is called I now. And I want to construct a triangle such that O is the circumcenter and I is the incenter. If I construct such a triangle, then do you see that the circumradius, the in radius of that triangle will be smaller because of that relation? So I just need to construct one triangle for which I is the incenter. And that, let me draw the diameter also. So I will pick the easiest triangle which I can form, right? Isosceles triangle. And so what will be one vertex of my isosceles triangle?
One of the 2 points.
Yes, and generally, A will lie on this side, right? So this is point A. So I just need to locate the points B and C such that I is the incenter. So what do you know about incenter?
Even B has 90 plus.
Yes, but I don't know angle A. What is this point, by the way? No, but more important is AI, right? Where AI meets the circumcircle again, what we call. If I call this point L, so take your compass, place it on L, draw this arc. So whatever this triangle is formed, the in circle of that triangle will have a radius small r, and that is that same r. So you found r. Okay, are you following this? Okay, we did it very quickly, but I hope you get the logic. Actually, this question is part of one larger family of questions we are going to do, where you have to construct a circle which satisfies three conditions. It passes through any point, it is tangent to any line, and it is tangent to any circle. So here the three objects were special. That point was here, the line was the diameter and the circle. But I can ask this question, I'm going to draw any circle in the plane, any line and any point, and now construct with ruler and compass a circle which passes through this point and is tangent to this. So this problem we are going to do in future, but this was one nice special case of that. Okay. But anyway, we are out of time. So I will post the practice problems for you on WhatsApp, and we'll meet on next Sunday. Okay, thank you.
Bye, sir. Thank you, sir.
Thank you. Bye.
Bye, sir.
Bye.
Bye, sir. Thank you, sir.